Okay, everyone, welcome to OWASP London chapter. This is our Halloween meeting, and because it's Halloween, I'm going to wear the hat. Yay! Welcome, everyone. We are hopefully live streaming on YouTube. It's a bit of a tricky setup because I have little microphones which are going through Zoom. So if someone is actually watching OWASP London YouTube channel, if you will confirm that there is actually an audio, if I'm audible, because I do have a lapel mic. Tonight's meeting, as you see, kindly hosted by Civo Tech Junction, and the food and drink is sponsored by Apiro. I hope you all managed to get a slice of pizza and some drinks. I hope we have some more. We're actually going to go to the pub for the after party after this event. For those of you who don't know me, my name is Stepanyan. I'm OWASP London chapter leader. We also have Andra. Andra, you in the audience? Can you stand up? And yeah, she's right at the back waving. We also have the third chapter leader, Sharif Mansour, but he is actually away today because he has a very valid reason for his absence, because he's trick-or-treating with his children. So that's us. If you're going to tweet about this event tonight, please do use hashtag OWASP London and mention us, because we are OWASP London on Twitter, or it's now called X, thanks Elon Musk. Just a quick reminder of OWASP Code of Conduct. We are a very nice and welcoming and friendly community. Please be nice and respectful to each other. No tricks, please. We have treats for you. Okay, there's celebration treats for everyone. I hope everyone managed to grab a slice of pizza and also a sweet. So agenda for tonight, I'm going to do an introduction, and we actually have some guests tonight, which hopefully will be able to join me on stage. Then we're going to have Petra talking about AI and AppSec, and are we finally on the verge of a big breakthrough? Followed by Q&A. We're then going to have Ella speaking about proactive risk detection at the design stage. And then we're going to have John McCoy, a guest speaker all the way from California, with a lightning talk on how to strengthen AppSec efforts. Then we are going to have a raffle. So there will be a prize given ceremony, which will take us a few minutes to set up. So make sure you actually all scan the QR code that I was sharing earlier. It's also available on some A4 pieces of paper printed and left on the tables. I have a slide, so please, if you have not yet scanned it, please make sure you scan it. Only those present in the audience, of course, can win it, because there are people watching us live on YouTube. And sorry, you cannot win the prize if you're not here. And then at 9 p.m., we're going to be kicked out from here. So please help us clean up before we leave. And we're going to go to the pub, which is the Angel. Here is the QR code one more time. Let me just move the screen sharing Zoom thingy out of the way so you could actually scan this QR code. And after a short registration form, you will get a chance to win this MetaQuest 3. We also, from OWASP, we threw in a deck of cornucopia cards. So there will be a prize from OWASP as well. So who is here for the first time? Wow, a lot of you. So we are very glad to see you here. I have no idea how you figured out how to find us, but to make sure you do not miss the next event, right? Here are all the different ways how you can keep in touch with us. So, of course, we have a webpage. Those of you who prefer getting emails, we have the old-fashioned mailing list, which is available. The link is available on the webpage. You can follow us on Twitter, on Facebook, on Meetup. You can watch all the recordings of all the events on YouTube, and you can watch us live. We are also on LinkedIn. You can follow us on OWASP London, also on Eventbrite. We also have OWASP Slack. If you need an invite, please come and see me later on. I'll tell you how to get onto OWASP Slack. And we are there as Chapter London channel. Now, usually at this stage, I will need to play a video with the introduction of what OWASP is. And I'm risking a horrible echo, but I'm going to try to turn up the volume on my Mac and play the video. Let's give it a try. Now, at this stage, you see, I thought this was going to be echo, so you really probably need two laptops for this. But let me see if you can hear this. No, hang on. That's not working. I need to wait because it's echoing. Okay. But let me see if you can hear this.
OWASP is a nonprofit that stands for the Open Web Application Security Project. OWASP is a community of developers, technologists, and evangelists improving the security of software through tools and resources. OWASP has 100 plus active projects, and new project applications are submitted weekly. Projects are open source and are built by a community of volunteers, people just like you. Community and networking. There are hundreds of local chapters worldwide and thousands of members. Meetings are free and open to everyone. They include training, talks, and networking opportunities. Education and training. OWASP hosts many events each year. They are a great way to improve your skills, build your professional network, and learn about new trends in the industry. One of the many ways you can get involved is to become a member. The membership benefits include discounts for events and trainings, your own OWASP email address and Google Workspace access, a vote in our OWASP Global Board elections, and recently, OWASP added a brand new member benefit, access to hands-on application security training through the OWASP Secure Flag Open Platform. Join us and become a member today.
Okay, I hope that echo wasn't too bad. I could definitely hear it. But a few updates on the memberships. Obviously, as it was said, we do have member benefits available, which are listed on the membership portal. We do have a brand new OWASP membership benefit, which is a checkmarks code bashing secure coding training system. So if you want to train your developers, ask them to join OWASP as members, and they will have free access to this awesome system. Okay, and OWASP membership costs $50 US a year. Students get a discount, and you can also become a corporate supporter if you represent a company. We are supported by a lot of corporate supporters. If you are not a member yet, you can become a member by visiting owasp.org/membership or just clicking the join button on any OWASP page. There is one other benefit of becoming an OWASP member, apart from everything which is listed on the screen, right, is if you become a member tonight and you will show me on your mobile phone the email from OWASP saying that you become a member, you will have this exclusive OWASP member sticker for your laptop. And one person, who was that person? Can you raise the hand? There's one guy. Yay! There you go. You got the sticker. You see, there's a sticker there. So yeah, if you do the same thing, if you become a member and show me the email, you will get this wonderful sticker. Right, we had board elections. So the one benefit of membership is that you can be voted as a board member. The elections just finished. We will find out who is going to be on board tomorrow. Shout out to our sponsors. These are all OWASP global sponsors. If your organization is looking for a way to support this awesome community, please do join this growing list and become a supporter of OWASP to support our efforts, our community, our projects. And we are proud because we have quite a few sponsors who are sponsoring us here in London. So these are all our London supporters. And if you want to join the list of our supporters, please do join and contact us to become a sponsor. We also have people who have kindly provided space for the meeting. So we are in Sivo space tonight. I'd like to say a big thank you to Sivo and to our charitable supporter, Piero. Let's thank him with a big round of applause. Because without them, this wouldn't be possible, right? And I wouldn't be on this stage. Right, I think I'm going to put the hat off because it's getting warm. This screen is so hot. Right, okay. So for those of you who become members, there's going to be, we do have a membership system, but there's going to be a little change on the membership because they have a new association management system. And we actually have Star Brown, who's the head of projects at OWASP. She came all the way from America. Star, can you please come on stage and tell people about AMS? Just for 2 minutes, yeah. We're interested to find out when it's going to be available and what people will be able to do.
Hi, I'm Star. So the AMS is Association Management system and or membership system. It depends on the use. We're using it for members, and for it, we will have a beautiful place for people to actually be members within an internet-based solution. Right now, it's a little not very user-friendly. It doesn't really have any social communication, and everything's a bit fractured. So there's a lot of work happening on the back end. You guys will be presented on the 12th with a brand new member experience. So when you are an OWASP member and you log in, you'll have a central portal for managing your membership, and that's what it is.
Awesome.
Yeah.
Thank you very much, Stan. Right. Okay, I'm gonna try to hold both microphones now. Okay, I've got Shruti in the audience. Shruti, please come on stage, because Shruti just won an OWASP award. She is the Web Application Security Person of the Year, and she won it because she's an Event Person of the Year. Hey, Shruti. Shruti is actually one of the first women who started coming to OWASP London meetups many years ago. Come on stage, Shruti, and this is a gift for you, and this is your WASP award, and you are Web Application Security Person of the Year. Congratulations. Right. Another thing that we do, which I started doing, you get an NFT for being here because you're present here tonight. So there's a type of NFT called Proof of Attendance Protocol, or POAP NFTs. So these things are just like Pokemons. You have to collect them all to prove that you are actually attending and active in this community. So these are all the ones that we issued before. And tonight you're going to get this exclusive Halloween edition of OWASP London POAP NFT. So there you go. That is how you can get it. Please come and see me. You can only collect it from my phone. I have a application called Kiosk, which is running QR codes. And you scan a QR code, and you can then get this NFT in your crypto wallet. If you don't yet have a wallet, you can collect it using your email address. And then when you install a wallet, you can transfer it to your crypto wallet. So yeah, special NFT tonight. All right, let me see if I can move on to the next slide. We do have a merch store. So if you want to buy some OWASP gear, t-shirts, hoodies, baseball caps, and even masks, we have them. Quick shout out to conferences that we had. We just had Global AppSec Lisbon in June, which was an awesome conference. And we also had San Francisco last month. Both awesome conferences. There was, I think, 1,000 attendees at each. Very good. Next year, we're going to have OWASP Global AppSec Conference in Barcelona. So that is the date. So this will be the last week of May. Right. Okay. Now, quick shout out to Project Summit. The reason why we have quite a few of OWASP people from USA and some other countries, from Switzerland, I believe, is because next week we're going to have a Project Summit, and Summit will be the same place where we usually have it, at the Center Parcs near Bedford. This is the agenda for the first 3 days. So those of you who signed up, we hope to see you there. If you missed the announcement and you're not there, make sure you sign up next year. Right. So quick shout out to OWASP projects. We have 250 free and open source projects for everyone. We have flagship project, lab project, incubator projects, because they're all open source. You can join and contribute, please, because that's the whole idea, right? So even things like OWASP Top 10, if you want to contribute to OWASP Top 10, you can do it. But tonight I want to give shout out to one OWASP project called OWASP Amass. This is our flagship project. And the reason why I want to do it is because we have the project leader of OWASP Amass, Jeff Foley, here all the way from New York. Hey, Jeff. And can I just stick this onto so people online could feel?
Can you hear me? Excellent. Yeah, so this is exciting for me. This is the first time I've physically been at OWASP London chapter. And the reason it's so important is that London actually has a special meaning to the Amass project, since Sharif kind of worked with me to originally donate the project to OWASP. And London was the first chapter that gave, say, shout out to this project and allowed us to speak publicly about this project. So very important place, even though I haven't been able to be here until now. Pleasure to be here though. So The Amass project, just real quick, is understand the attack surface of the organization. So now we can dig deep into what weaknesses could potentially exist in those exposed assets and applications. You kind of can't drill down into these things if you don't even know they're there, right? So that's the idea of the project, is let's put the spotlight on these exposed assets so we know how to prioritize where should we be looking when we're doing things like application security and what have you. Real quick, because I realize we're short on time. This project is quite active. We're expanding it all the time. As Sam said, we can always use more people to help with it. And the mission is broadening, seems like every year. So it started off rather simple. I would say now it's become, it's a broad mission for this project. Come to our, well, to the project page, to the GitHub, and to our Discord if you would like to learn more about what exactly we're focused on, what tasks you could contribute to, and you know, where we're taking this exciting project.
Excellent.
All right, thank you.
Thank you very much. Can I just get the mic? So very quickly, is there anyone in the audience actually using OWASP Amass project by the show of hands? Wow, we have quite a few people. Awesome. So we have the project leader here. So come and catch Jeff after the event, and we'll go to the pub for more drinks. One interesting fact about Amass is that Jeff presented OWASP Amass to OWASP London remotely several years ago. The recording of that talk is available on OWASP London YouTube channel. Please go and check it out. Another shout out to another project, which is Cyclone DX, a software bill of materials specification. That just became an international standard. There's people who use JavaScript, they will be familiar with ECMA and Cyclone DX. OWASP Cyclone DX is the first OWASP project which became an international standard, which is now called ECMA 424. So go and check it out. Okay, so tonight is going to be quite difficult for me to ask questions. Because there's so many of you. If you have a question as the presenter is speaking, can you please go to slide.do/OWASP? If it doesn't work, you can enter the code OWASP and you can ask your question there, and then we'll put it on screen and the speakers will be able to answer your questions. Now, the first speaker we have is Petra. So Petra, are you joining us on Zoom so you can share your presentation instead of sharing my screen with me? I'm able to share. Yes, that's right. I'm able to share. That. Oh, sorry, I forgot. Yeah, there you go. So many things to do, but I can actually share your presentation. Just 1 second. Let me find it. That's true. Okay. Let me go and find the correct page. Okay, that is going to be AI and threat modeling, right? Which is this one. 1 second. Chrome. Let me see. I need to probably try to do the sharing thing one more time. And okay, Google Chrome. That's the one I want to share. All right, and let me do a slide. And there you go. I will give you the clicker. Right. Okay. And I think you can put your laptop here, and here's the clicker for you. I know Petra is going to do an introduction. I'm actually, Petra, can I also ask you to put this maybe here? So people
like here?
Yeah. Okay.
How's now? Can you guys hear me? Is it
I'll
good?
give you the microphone. Okay.
Ah,
so
okay.
there you go. So quick introduction. So few of you know Petra from Project Summits, because Petra presented a lot, and she worked with one of our OWASP London legends, with Dennis Cruz back in Blastwall. And I'm sure Petra's going to cover it, but there's a fun fact that I know about Petra that not many people know about. She is actually original not technical person. She's a medical doctor in emergency medicine, and she made the journey all the way to cybersecurity, threat modeling, and now we're gonna hear Petra talk a bit about AI. Let's all give Petra a very warm welcome. Oh, yeah.
Thank you. That was an amazing introduction. So I'm here to talk about AI, and I'm really sorry about the buzzword. Is there anyone in this room who didn't think, oh gosh, another talk about AI? Who didn't think so? Okay, cool. All right, I do have a challenge then. Cool. Okay, I'll take that. So I also have a confession in the synopsis. I was mentioning the word revolution, but I think, if we think about true meaning of the word revolution, it's like, out with the old, in with the new, French Revolution, heads were cutting off. I think here we're more talking about a reform, an iterative change to make something better. So I promise no heads will, fly with us. And let's see if this works. Cool. So who am I? Sam gave me an amazing introduction. So right now I am head of information security. I am currently happily unemployed, but next week I'm starting my new job, head of information security in Newman. And as Sam mentioned, I did used to be an A&E doctor. However, I was always passionate about technology, and that kind of led me to pivot to cybersecurity. So during my pivoting to cybersecurity, while I was working for Dennis, like Sam mentioned, I was working on this project that was using machine learning to detect unknown malware and basically in files. Now that project is a patent, not that I'm bragging at all. But this is where I got introduced to the exciting world of machine learning and AI. And maybe this will entice you to pay attention to kind of, to what I'm saying now. So I'm also like a huge fan of threat modeling. I do believe that threat modeling is the best way that you can do risk modeling in an organization. I think we need to threat model everything, not just applications, but processes, because ultimately we're asking what can go wrong. So we are also improving system architecture, we're improving the software quality, and obviously the security. So having said all of that, I'm not an AI expert by any means. However, I'm hoping to just bring an interesting discussion to you today. So I'm going to talk about what is AI, the current state of AI and security, the potential that it has, and the limitations that potentially can come along. Now, let me start about what is AI. I don't want to teach you guys here what AI is, because I think everyone knows it. But everyone has its own concept of it. And I want to just talk about the context in which we talk about AI outside of data science, in industries like cybersecurity, for example. So I'm going to take you a little bit back to the 1950s. There was this idea of machine intelligence that Alan Turing introduced. Now, on that note, I want to ask, maybe you guys can raise your hand. Who has actually heard of the Voigt-Kampff test? Ooh, one hand. Okay. Who heard about the Turing test? All right, cool. Sorry, Turing. I apologize. Turing test. Cool. So actually, the Voigt-Kampff test is the Turing test inside the movie Blade Runner. And it was famously depicted, with this scene. And then when we moved on into the next few decades, actually scientists got really, even back then, in the 50s and 60s, scientists did get quite excited about neural networks. Just thinking about using the way the human brain thinks and replicating that into a machine sounded super exciting. However, they were very limited with, the processing power, because computers back then were like made huge. They were big as building blocks. So that was the limitation. That's kind of where it stopped. But this is what paved the way to this idea. And then moving more further down the 90s and noughties, we actually started to use machine learning a lot. And what machine learning was actually glorified statistical models on steroids. So, early adopters like Spotify and Netflix could actually use machine learning to learn about, someone's preferences and then predict what they would like to see next. And that, earned them a lot of money. That made, paved the way for their success. And there on top of that, we started to build large data sets. And this is what enabled us to progress further. And this is when, for example, AI started beating humans at chess. And then we moved on into the next decade, where we actually started utilizing deep learning a lot. So we started, getting tons of data, and we were putting all that data into the neural networks. So we resuscitated them. And this is what paved the way, for example, to, automated vehicles, to using it in medical diagnostics, to using it in facial recognitions. And then further down the line, we got to LLMs. And this was the biggest excitement. And even the LLMs actually have passed the Turing test. I think that was back in February. So for this presentation, when I talk about AI, I'm going to talk about it in the context of LLMs and some machine learning. Okay. Oh. Missed a slide, actually. This was the famous Turing Vukmirović test. So what do we talk about when we mention AI in cybersecurity? I think these days, there's this huge sentiment of doom and gloom. And even if you ask ChatGPT, for example, what are the sentiments around cybersecurity and AI, it will kind of tell you prevalence is the concern, and then you have the optimism. So we talk a lot about the privacy and security implications of AI. We also talk about how we don't trust it. We don't trust it to make decisions for us just yet. We believe it hallucinates, so we're super scared of these hallucinations and their ramifications. However, we do start to talk about their benefits, and one of the benefits is, let's say, threat detection or automating, but only with the man in the loop. So this is kind of the sentiment. What I want to talk today is actually the last one, the benefits. Is like, if as an industry we decide to embrace AI, which I think we should, we can have a lot of benefits, because actually threat actors are already using it, so why shouldn't we? And this is kind of where we get to the established usage. So, what do we actually trust it to do? We trust it to do threat detection, we trust it to do some automation, and we trust it to do risk assessments. So essentially, to sum it up, we trust LLMs to read language, and we also trust machine learning to create predictions. And this is where we're actually comfortable. We're comfortable also automation, as long as there is like a man in the loop to kind of review this. If it gives us remediation advice, and here you have a Terraform template to remediate your cloud misconfigurations, we do need to check that Terraform. We're not going to just deploy it in our environment. But this is where we started to trust it. Now, there is areas where now it's evolving, where we're only just at the beginning to using it and actually giving it some kind of credit. One of it is vulnerability and threat prioritization. So for example, we're using it nowadays in the ASPM. So there's ASPMs like, Phoenix Security, Cycode, Armor Code, that are starting to use it as something that helps them prioritize. And that's always been an issue in cybersecurity, right? We're also using it in penetration testing. So for example, Simulate uses it to, you can have your attack trees, and based on that, it creates attack scenarios that then pen testers can use to attack your application. Also, we have something like Verge GPT, which essentially, when we intercept the traffic, we get the LLM to make sense of that traffic and help us find the vulnerabilities that maybe we wouldn't find just with our manual reviews. And then ultimately, we're using it also in code scanning, like, SNCC, and all the big SaaS providers are starting to kind of utilize AI. Ultimately, we're also going to start using it now in security reviews and threat modeling. And this is where we still haven't kind of got it right just yet, but this is what I want to talk today. Because essentially what we want AI to be is our own kind of application security engineer or code assistant. Now, before I dig into how this could potentially be done, I want to kind of try and answer the question why we would even go there. Like, what is the problem with today's threat modeling? And today's threat modeling is, as we know, all of us who do it, is a very manual process. So essentially, you have this complexity of creating a diagram, creating a meeting. It all takes a lot of time and resources to do, while we want to move quickly. Then you have the adoption integration issues. So it's very hard to integrate it into an SDLC, which is agile, because there's so many quick iterations and deployments, while we as security are kind of bottlenecks, telling them, hey, wait, stop, let's do a threat model before production. So there's a lot of resistance here as well. And it's also daunting. I know a lot of security engineers who are afraid to do them because they think they don't know how to do them. And even developers don't know how to do them. It is kind of like a specialized skill set. There's also a problem with scaling. It's very hard to do a threat model on large, complex systems. You need to split it into smaller threat models, and it takes time. And then in the end, when we actually find our findings of the threat model, we need to actually prioritize it, because a lot of times we just talk about theoretical threats that don't matter, that have nothing to do with our attack surface, for example. And what are the consequences? Why is this a problem? Where we get a lack of communication between the teams, we get critical findings going into production, and then we get breaches. And yeah, nobody wants breaches. So to discuss ultimately what we want to achieve, we kind of need to understand what we want. What we do want is we want some sort of automation. But this automation might need man in the loop, right? We might not be realistic if we think we can get full automation for security reviews and threat modeling. The second thing that we need is actually actionable findings, because how many of you guys have had a threat model report and it ended up just on a Confluence page or Notion page, but it never got actioned? So we need some kind of finding that will then get actioned and moved forward. And then also, this is where we get to the integration and continuous testing and enforcement. So for example, if a finding on a threat model is that we need to implement authentication on a critical endpoint, we don't want that to be just a point in time, because someone can go and remove that authentication later down the line. So what we really want is something that will actually continuously test if our threat model is being enforced. And now we're getting to our technical adoption and challenges of AI and threat modeling. As we said, threat modeling has a lot of complexities. So it will have like a lot of inputs, like a diagram, a description, you have your decompose the application components, storage. You need to create your threat personas, your attack vectors. You need your business context. And it's all very complex for an AI agent to do. You also need standards, right? Because if you want a standardized output, you need the industry to agree on standards, and we still haven't agreed on it. I still hear a lot of people talking about vulnerabilities found during threat modeling, while the output should be more threats. And I still see people mixing those two up. So we still are not there yet in agreeing as an industry of like, what do we actually want to achieve with the threat model? Also, we need a way to do code comprehension. So we need the ability to actually read the whole code to be able to automate it and then make sense of it, the business logic, and then present that to our threat modeler. There's a cost issue. The more calls we do to our LLMs, the more it costs us. Also, if we want to deploy it on site, the GPU cost will raise our cloud provider's cost. There's the false positives and hallucinations. For example, I was playing a lot with creating threads that then link to Mitra CapEx. And I found ChatGPT fascinatingly hallucinating about those. Like, it invents them, it creates some IDs and KPIs that don't even exist. It's super interesting. And then there's a huge problem of lack of data sets, because nobody will do a threat model and then open source the code and the threat model itself if it's something that's internal. Yes, maybe if it's open source, that can happen, but if it's internal, nobody will do it. So we don't have available data sets that can enable us to actually train and fine-tune our LLMs. And then there is, the whole mistrust that I spoke about before. We still don't trust it to make security decisions for us. So what are the opportunities actually? Like, what can actually be done? I see this can be done in some multiple ways. We can do threat modeling from attributes. I called it TMFA. I'll explain it in a bit. And we can do threat modeling from the code. And then we can also do security design reviews. And we can do the continuous monitoring and enforcement. I'm going to talk for a moment about the TMFA. So basically what we do with TMFA is we have our attributes. So we decompose the application, and then we identify and prioritize, our threats, our vulnerabilities, our risks, and then we get, as an output, actionable advice. So essentially, we feed all of this information to the LLM, but we actually feed it in a way that maybe if we have a diagram, we can derive a lot of things from the diagram. So we make it easier for the security engineer to go through this flow. So instead of kind of spending hours and hours trying to read the diagram and asking people around, or on a meeting, perhaps if we just start with a good diagram, we can get a lot of these things put in. And then we feed it to the LLM, and then the LLM, if it's very well trained and fine-tuned, it can give us those, threats and vulnerabilities and risks. Now there is, in terms of the players on the market, there is like, you have the open source one, which is Stride GPT. Don't know if anyone played with it here. That uses, the Stride methodology to derive your threats. You have an attack tree, which is also a really cool tool. You just have to enter a lot of information. You give it a good description, gives you like nice visual attack trees. And then you have some up and coming, emerging players in the market like DevArmor, who are trying to do, code and application driven threat modeling. You have Threat Modeler, who's trying to do it with infrastructure as code. You have Apiro, who's doing security design reviews with AI. So there is emerging players in the market who are leading towards that. And then I'm going to talk briefly, due to time, about the threat modeling from code. Now, can we ever achieve full automation of threat modeling? Does anyone believe here that we can do it ever? Cool. Some optimists, some optimists. This is, I think this threat modeling from code is as close as it gets. Essentially, you need to get the LLM to analyze the whole code base. And it needs to not only analyze the code base, but actually needs to know what to focus on from the whole code base. It needs to understand the business logic, and it needs to understand the relationships between the various code elements. It needs to understand the infrastructure, so maybe there can be some infrastructure as code there as well. And it needs to be able to build a proper data flow between those elements and components. And then it needs to be able to standardize your threats, risks, and control in a meaningful way. It needs to be creative, but not too creative, because we don't want it to hallucinate. And it needs to be comprehensive, but not too comprehensive / noisy. Now, how can this be achieved? Potentially with RAG. So this is retrieval augmented generation. Essentially, what we do is from the code, we create vector embeddings. And then these vector embeddings are basically numerical data, which allows the system to quickly retrieve that data. Because they are grouped into a meaningful semantic way, we can quickly grab them and kind of find what we're looking for based on semantics. And this process can potentially, improve the accuracy and contextual relevance of the LLM. And also help us reduce the cost, because if we feed the whole code base to the LLM, it's going to cost us a lot. And then, you know, if we're going to be super optimistic, one day we're going to have adaptive threat modeling, which means that, you know, our threat models will adapt in real time and dynamically adjust. We're going to have continuous threat modeling and enforcement, which means that not only we will look at what our threat modeling found, but check the code if anything has changed since then, if anyone is actually going against what we said in the threat model. And then we're going to have also the business context pouring into all of this for our perfect threat model. So there will be some market disruptors, and I think it's going to be really exciting to see in the next few years how this will come out and how this will all kind of turn into some hopefully great tools that can help the community. But we can also help the community. I'm thinking I'm going to create an OWASP project, so please contact me and join me. What I want to do is I want to standardize the threat modeling inputs and outputs in like a schema, JSON schema format, and create a huge data set of threat models. So this can, you know, first of all, the community can learn from it. We can all collaborate on threat modeling. And secondly, this can actually help fine-tune LLMs in the future and help us, you know, get better at fighting the threat actors. Yeah, sorry, I'm rushing through the slides. And yeah, so these are the, and that's it. Thank you very much. I've gone 2 minutes. Questions?
Questions? Yes, question time. You still have your microphone
okay.
on. Okay. AI question.
Very nice presentation. In the beginning, you were saying that currently we don't really trust AI to maybe help us. I'm going to ask, do you think it is? I think that depends on your medical knowledge at the same time. Also, plus your memory. Do you think it's much more to do with psychologically humans don't really tend to trust something that's totally new? Is it? Or is it technologically?
I think it's two things. I think it's two things. One thing is exactly like you said, it's the psychology of, you know, something new, like embracing something new and something that we know could be error prone and could get us in trouble, right? And then the second thing, I think as security engineers, analysts, experts, we all have this little dose of paranoia in us. And I think that's also, you know, kind of niche in the security world. And I think that's what makes us good at security, right? Like we do need that paranoia, but you know, that paranoia is slightly extending to AI as well.
There is one question online, and by the way, you can all ask questions on your mobile phone. If you go to slide.do/OWASP. The question is, AI is disrupting the software development industry. How do you think this will impact AppSec?
Well, in exactly this way. So software developers are already using AI to actually, you know, create functions and to develop faster. And we are going to do the same. We're going to read the code. We're going to make sense of it. And instead of having long threat modeling sessions, we're going to have like AI tell us everything that we need to know. So we're going to go hand in hand with that. And that's why I think, yes, definitely there's going to be some disruptors in the market.
I can see the question back. Yeah, really
like this.
Every time you go through the process of developing a threat problem and using AI, how often during the early stage, middle stage, or the test stage, you ask yourself, should I continue developing this? And you ever found yourself questioning the ethics of what you're developing and what up to your said?
I can maybe come closer and help. So your question, just to try to understand the question better, your question is using AI for threat modeling ethical, or is it what we're developing and threat modeling?
It's a part of that. We shouldn't be doing it. So we ask the question, what can possibly go wrong?
Yeah.
We shouldn't be doing this at all, right? Because of ethical.
I mean, I think we all did that, right? Like when we were doing threat models, I think there was so many situations where we were thinking like, okay, this is going to go wrong in so many ways and we should just stop. We should just cancel even the whole project, right? Probably the product teams would disagree, but so if we apply this to AI, like, do we ever ask ourselves, you know, should we develop something that is going to be so powerful and help us? It could, you know, if you're trying to kind of make that connection, yes, of course. There's a lot of discussions how using AI is going to be ethical or not. But I think, in my opinion, you know, the attackers are already doing it and they're not questioning it. And we should kind of jump on that train.
Because the attackers are doing it, we should not do it.
Yeah, yeah, and they're not questioning it. They're not stopping at one point questioning it. So.
Okay, there's another question. Cool.
How AI-based platform assists in identifying risk for medical IoT devices?
Oh, medical question. Petra, you are a medical doctor, right? Medical devices, how bad can it get?
So I think we do need to threat model medical devices even more than we probably need to threat model, you know, some kind of product, because it's about human lives, right? I think this will help us a lot because, like I said, we're not expecting full automation. We're expecting the security engineer, the one who's doing the threat modeling, to be there in the loop. So if we're doing a threat model on that, I think it can be only helpful because it might help us think of the threats that we never thought before, because it has the knowledge that we don't have, right? It's trained on all the data from the internet, and it might know more than we do even about medical IoT devices, especially because that's a niche area, right? So I think it can be super helpful as long as we are there to be sensible and to judge it and to say, hey, okay, I agree, this is a valid threat, or, you know, something else is completely invalid and it's hallucinating.
I think, oh, Hardy?
Back a long way. What they see on the system. That's what we have. More people use it. It's my big worry about query AI. Paid information providers, you can't have that stuff. And free information providers are easily agenda and money to skew the information. Yeah. We were looking at in AI that we get very accurate answers, wrong information.
Yeah, a very good question. So data poisoning and pollution is how do we deal with that, Petra? Any suggestions?
So with the pollution, I think obviously, first of all, we need to just make sure that we are very much in charge of what we, how we fine tune our models. So there needs to be obviously whoever is going to have this product needs to make sure that their own internal security is safe. Now, the generic models as well, we can, you know, maybe use open source models that potentially might not be influenced as easily, put it aside, isolate them. But to also answer your question about how we're also, it's a very good point about how we're getting so used to AI that we just start blindly believing it. I think there needs to be whatever tool we use to threat model with AI, there needs to be these guardrails, these checkpoints where actually there is a prompt to say, hey, is this correct? Do you agree with this? Like everything needs to be kind of checked, and potentially even have another AI agent validating the work of the first one.
Basically have safeguards.
Yeah.
Yeah.
Forward, right? At the end of the day. One have safeguards, but you also need to have human oversight. You have to have
Exactly.
real
Man in the
human
loop. Yeah.
oversight. And I think generally, entrepreneurs need to think of AI as an assistant, not as a pure front-end center. Say, okay, say for example, if an AI is determining about, let's say, benefits, for example, and if the AI maybe has made a mistake or has overlooked something in the application, and then, as you know, that it does happen in some cases that maybe one department and other places that it spits out an answer, and they take the decision of the AI or the AI models as wrong, isn't it? It's wrong and as what said.
The trustworthiness, right? Basically.
Yeah. Yeah, I agree.
Just one more question. I saw the question.
Here. Now my question was like on threatening itself, you keep that every developer threatening is it a job of security engineer or developer? Do you think they see the value of threatening?
It's good exercise for you, huh?
Good thing
Especially with that case.
Yeah. So I think the only way to make threat models scale is to actually get developers to do it. I don't think every developer should do it. I think we should have like security champions. But I think the only way to scale it is to actually get, designated people in the development teams to do it and have something to facilitate that. And the security engineers are the ones who can review the threat models and kind of validate it and, be the ones who are saying it. In some smaller companies, yes, it can be the job of a security engineer and they can actually do those. But I think the only way to make it scale with small security teams and, large development teams is to get the developers involved. And I think in my experience, I actually do see the value, because a lot of times you can actually find things in the system architecture that can go wrong, and actually you improve the software quality, you improve the system quality. So it's not just a security activity, it becomes more like a architectural activity where there can be more benefits for the business than just on the security side. But that's my opinion.
Excellent. Thanks very much, Petra. Let's everyone. Please stop up on your pizza and your drinks and be back here in
Thank you. Thank you. Yeah, I was a bit nervous. I was like going too fast with my
Ted did send you an email. Your email address was covered up.
Oh, is it?
Petra Vukmirović.
Get your mic.
Yeah.
Should work.
Oh, yeah. Sorry, I stole it.
On the side of things, one of the forthcoming projects.
That's very good. That's very good.
Oh, yeah, LT. Oh, 1 second. Ella, are you ready? If you want to set up your laptop there and then join the Zoom conference.
What? Sorry, what?
Yes. NFT time.
Yeah.
In the meantime, if anyone wants an NFT, the proof of attendance NFT, you can come and collect it from me. I'm here on stage, sharing QR code for proof of attendance NFT. You want one more? There is another one.
You're like superheroes.
That's what I do. 1 second, let me find videos. First. Okay.
Petra computer?
No, it's a mine. Okay, you do I need USB or USB-C? Okay.
Thank you.
Don't forget to collect your proof of attendance NFT. Available.
How long is the break? How long is the break?
It's 10 minutes, so about yeah, 5 minutes.
You want me to start then?
You can send it to your email address. Oh, really? Okay, so you have a wallet, you just paste the wallet address. If you don't have it, send put the email address. I'll tell you how to wallet. Start with your email address. Download Trust Wallet. Section. There is a Wi-Fi. There is a Wi-Fi. Address.
We have
You have 40 minutes. 45 minutes, sorry, 45 minutes. We started 3 minutes. Okay, 7 people already connected. And Ella, can I please attach this to you? So can you just stick it
yeah, you want me to
with it on your shirt? Maybe it will be easier, but
this? Oh, I can do it
you just need to.
here,
Yes.
like that.
Awesome.
Thank you.
Okay, everyone, please take your seats. This is time for our next presenter.
No, not last one. Oh, you said next. I thought you said last. Sorry. Simon. I need to ask you to take some pictures.
Yeah, I'm doing that. All
Thank
right.
you. Here. Okay. Okay.
Okay, Ron. So Ella is a data scientist. So as a data scientist, she actually does AI machine learning as her main job. So let me see if the microphone is still. And she is going to talk us about how and why we can reduce risk proactively using scheme.set. That's all. Welcome, Ella.
Thank you, Sam. Thank you. So hi, everyone. I'm Ella. First of all, thanks, Petra, for the previous talk. I feel like it was a great starter for what I'm going to talk about. I feel like she just led the stage for me. So thank you. And I agree 100% with the things that she said. I'm looking forward to cooperate in the future. So let's start from the top. I'm Ella. I'm very excited to be here. What a great community you guys have here at OWASP London. I'm super grateful for being here. So as Sam mentioned, I'm a data scientist, and true fact, I'm actually a physicist. So I'm just excited about engaging in complex problems, whether it's quantum mechanics or cybersecurity. And I've been a data scientist for quite some time now in different domains, from e-commerce to legal tech and application security. Right now, I'm leading the data science team at Apiro, an ASPM platform that gives you full visibility into your source code and help you prioritize and mitigate your security risks. Okay. So I'm going to talk about secure by design. I'm going to talk about what does it mean to do the secure by design process, what are the challenges, and how we can use AI to automate that process. So a lot of things from previous talks are kind of getting the dots connected. And I really love for you to ask questions during the lecture. If you have any, if you want to comment or ask something, if you want me to dive deeper into something I've said, let's make it more interactive and less of a monologue. That'll be great for me. Right, so let's start. All right, so when we're talking about application security, we can definitely identify risks when they are in your production environment. And we can identify exposed secrets, unauthorized APIs, sensitive data being written to logs, and those kind of things. When they are already in your production environment, then first of all, they can be exploited, which is not great. And it's also going to take a lot of time and effort to fix them. It has to go through the entire SDLC process before the risk can be fixed, and it's a tedious process, and we don't want to get to that point. So sometimes we're trying to prevent the risks from entering the production environment by scanning your pull requests, and that way, risk doesn't go into the production environment, but still code was being written and has to be fixed. So the dream is, what if you could prevent unsecured code from even getting into your pull request? And what if the developer had the countermeasures and the security concerns in his mind when he's writing the code? Now that would be the dream, right? And that's exactly what secure by design means. It means that we're proactively looking and finding risks before development begins. Now, I think it got tremendous potential, like Petra was saying. And the secure by design process includes threat modeling. And just to have like a quick glance, I'm sure there are some experts in here. So, sorry. So when we're conducting a threat model process, we start by mapping the assets and what we want to protect in our application. And then we will try and think, okay, how would this new feature that I'm developing going to look like having some kind of a diagram or a flowchart of how it would look. And that point we're going to, that's like third step is actually the hardest, where we wreck our brains on what could go wrong and where are the exploitation points and how an attacker could exploit them. And after we're done with the third part, then we have probably like a billion risks in our mind, and we have to prioritize and think, okay, what should I handle first? What's the most important one? How am I going to make sure each and every one of them is not entering my code? And fix your design accordingly, right? So the first, the last few steps are kind of iterative until you have all your concerns kind of covered. And I think, you know, like Petra mentioned, if this process was happening for all the feature designs that you have in your application, then I mean, we can all agree that the code would be much, much safer, right? Yeah, nodding, thank you. Thank you. But in real life, can you throw a number as to how many companies engage in threat modeling processes, like in percentage? Okay, what's the percentage of the companies that do secure by design and threat modeling processes? 20%, okay, 5%, okay. Well, I think I kind of like you said, maybe because when I was hearing that 30% of the companies are doing it, I was underwhelmed. I was thinking, how can it be that less than a third of the companies engage in secure by design and threat modeling processes? Because it holds so much potential. It could really prevent so many risks from entering the code. And when we stop it at an early stage, we save so many resources, right? So for me, it was shocking that less than a third of the companies are actually doing it. And the next question was why? Why do so little companies do it? What are the challenges? Why is it not happening always? Because it has so much potential. And so there are quite a few problems that we've mapped out. I think, like also Petra mentioned it, it takes a lot of time to conduct that process. So you cannot, I mean, most companies don't do secure by design and threat modeling processes for all the features that are being released, not even the important ones, because they don't have time for it. And there's not a real process of how we're making sure that we're reviewing all the important features and how we know that the steps we're pointing at are actually being taken into consideration. And it's hard, right? I mean, the diagram I was showing of how to do a threat model, you really have to know a lot, both about your application, but also about the threats that are out there. So it's not an easy task at all. And I mean, if you had all the time and knowledge in the world, then you might have been able to, you know, to resolve it and to overcome all of these challenges. I mean, just like to take a subjectivity, you could have 5 threat modelers working on the same feature and do a majority vote and having the best threat model in the world, not subjective. But you don't. You rarely have one threat modeler to work on a single feature. So for me, it all boils down to scale, just having too much and not being able to do it. And when it's a problem of scale, then it really, this is where AI shines, because this is really where LLMs and AI can come in hand and help in that scaling issue. Any questions so far? Going for the modeling here, okay. So this also kind of, I think, points out the problem where just yesterday, the CEO of Google said that 25% of, oh, I wanted to ask you what you think the percentage is. Okay, never mind. So 25% of the code written in Google is written by AI, 25%, and now we're 2024, okay? It's only gonna get worse from that point. And, you know, we can't keep up with that pace. It's so much code that is being written. There's so many features being developed at every point in time. Even though my product manager always tells me there's too little features we're developing, and I'm telling him, no, there's so much. And okay, that's just another work. And And it's really hard to keep up with the pace of coding and features and do a proper threat model for each of them. And if I tell a joke, you can laugh. Okay, it's really allowed, recommended. Okay, so we wanted to solve the issue of scaling secure by design and threat model processes. And we have, you know, it took a lot of trial and error. It took a lot of time and a lot of thought, talking to a lot of our customers and understanding what we want to do and how. But eventually we got the problem kind of nailed down to this process, but it's been a journey. And it's a process where we take all the features, design, contextualize them, and having them go through 3 steps. I'm going to elaborate on each one. Please stop me if you have any questions, okay? Okay. So the first step is detection. Now, sorry, just let me get a sip of water. No. Right? Okay. So the first step is detection. Now, this is where the first few iterations of Secure by Design for us were only focused on the first step because it's a super non-trivial one. We're looking at all of the design tickets that a company has, and we're trying to find which tickets are the ones that are interesting for review, which ones are the important ones, the ones that might introduce new risks into our systems. And when we studied that subject, we found that about 1 to 10% of the tickets will be those kind of tickets that we want to look at, because obviously we don't want to look at all the tickets that we have in our ticketing system, right? A lot of it is going to be garbage that doesn't need to be reviewed, but we want to find the ones that might introduce risks into our system. And that's super subjective task because different practitioners have different ways of defining it, right? So we came up with this long list of questions that we want to ask ourselves when we're doing the detection process. And we want to ask ourselves, okay, is there going to be a new API introduced? Is there going to be a change in an existing API? Is there going to be sensitive data handler? Just like a bunch of those questions. And also we ask which application is it going to go into, because that has a lot of weight in that decision as well. And finally, we did an experiment where we took 3 analysts and we gave them the same group of tickets, and we asked them to do the detection themselves and say, what do they think should go through review and what shouldn't? And what do you think was the level of agreement that the 3 analysts had? How much? Okay, but let's say like in percentage. 10%. Okay. Well, again, you're yeah, it's a little bit drastic, but they agreed on, because they had a very clear set of guidelines, so they weren't just operating on out of thin air, but they had a 50% ratio. But as a data scientist, when you have data that's agreed upon only in 50%, then it's gonna be a challenging task. Because the data, you don't know what's the true data here, what tells the true story. And we can't have 3 people constantly tagging tickets. So at this point, and again, as I've said, the first few versions, we were only doing the detection phase. And that low agreement level has made us realize that the first step is not enough. We have to do more. We have to understand. And what does it mean to understand? It means that we're going to add another step. Okay, not only we have an LLM that does the detection of tickets that should be going through security review, now we're going to understand them better. We're going to classify them into a category. For example, sensitive data handling, user permission, architectural changes, network, etc. And we're going to create a textual, human-readable explanation as to why this ticket was chosen. Okay, so that way, the person that's looking at the the section can, understand the logic, kind of see behind the mask of why this decision was made, okay? And that's the second step. So we're detecting and we're understanding the detection. Now, at this point in time, it was just a few weeks before launching this feature, and we were kind of proud of ourselves, opening up a champagne. Yeah, you figured it out, all right, and that's awesome. And then the product manager was like, "Why you're celebrating? You have so many features to develop." And thank you. And then just weeks before launch, Idan, our CEO, comes up and says, "Can you try and generate some security review questions? Maybe you can try and generate a threat model." And again, weeks before launching the feature, we're like, "Okay, we can try." And we did. Those were a few hectic weeks, but we taught the LLM to create specific security review questions on that ticket. And we taught the LLM to create threat model stories. And then once we did it, we looked at it and we said, okay, now it makes sense. Now we're actually we're doing so much. We're detecting, we're understanding, we're mitigating, we're creating countermeasures, we're helping the security practitioners to understand what's important to review, giving them guidelines for how to review it, and creating that conversation between the developer and the security practitioner where, it's all automatic and there are different models doing those work. And that makes sense to us. Okay, so questions so far? Okay. So just another short demonstration of what the entire flow looks like. So we're looking at all of the tickets that we have in ticketing systems, and we're combining them with the source code where it's going to be developed. We're ingesting everything into our models, and as the 3 steps I've shown before, we are detecting, understanding, and mitigating. Now, I think that in this point, we're ready to see an example of the entire process start to end. Unless someone wants to ask something. Okay. All right, so let's look at an example. Now, the process I've showed of detecting, understanding, mitigating is happening all the time for every single ticket that is being opened in the ticketing system or a ticket that is being updated. Every time we run the algorithm again and connecting those steps. Now, my example will start with a ticket being open. It's a little bit small, so I'll tell you what it says. It says that we want to develop chatbots with AI. Sorry, that's my gig, and we're going to develop a chatbot with AI that's going to do customer support. Now, our customer support guy, Ori, if you're listening, it's not a real ticket. We're not going to replace you. Don't worry, it's just a fake ticket. Okay, we're not going to replace you for now. So this ticket says we want to develop a chatbot with AI that's going to do customer support, and the chatbot is going to assist the customer, and so it will have access to customer data like orders and accounts, etc. Right now, okay. Now let's say I'm developing this feature, and actually I always wanted to develop a chatbot with AI, so let's do it sometime. Let's say I'm developing it, and I'm just starting to experiment. Okay, so I opened like this draft pull request where I'm experimenting. I'm doing some stuff, testing, and I've linked my pull request to the ticket. So now the ticket contains both the information of the pull request, and it can also contain a link to the repository. So we know that the code that is going to be written, that is described in the ticket, will reach, in this case, the LIM repository, which is our repository in Appiol. And now this is where the next step is, for me, most exciting, because This is where all the magic happens. I mean, it's not real magic, it's hard work of a lot of people for a lot of time. But when we, in Apiro, when we analyze the source code, then we have this huge inventory of APIs, of sensitive data classes, of authorization application security measures, and we know a lot of things about the source code. We know a lot about the repositories. And here you can just see a summary, but we know where the code is going to be integrated in, and that gives us a lot of context to understand the ticket, okay? Because you agree with me that if I was implementing the code in, I don't know, a test repository, mock repository, experimental repository, just for data nerds like us, then, and it's not exposed, not internet exposed, then maybe we wouldn't classify this ticket as risky. Why? Maybe we wouldn't want to have a security review of that ticket. So the context is everything for us in Apiro. Like we say, context is king. I know here Charles is the king, but in Apiro, context is king. And now I have all this information that I can enrich the ticket with. And by the way, we don't have to have it. I mean, we can have the entire process happening even without a pull request connection and a code connection. So in this point, I have all the information about the ticket, and I have all the information about the source code, and this is where we're going to activate our first LLM, which is the fine-tuned proprietary LLM that we trained. And it's going to say, I mean, it was trained to answer it has one job, to answer one question. How certain are you that this ticket should go through a security review process, secure by design process? And in that case, the confidence is 0.94. It answered that it should 94% certain that this ticket should go through a security review process. And this is relatively high, so we classify this ticket as risky and being a candidate for security review. Now, what's really cool about here is that the ticket was created on July 11, which is the same date as the risk was created. So we have, and it's just within the hour. I mean, it's a matter of running a few LLMs, and you have all of this process for all of your tickets all the time. You don't have to wait for someone to go over it, and it gives you so much power of scaling up and automating that process. So at that point, we're going to activate our second LLM, which is going to, again, classify to a category and create a free text explanation as to why this ticket requires security review. And it gives you, again, this kind of inside information as to why this decision was made. And you can choose if you want to agree with it or you disagree. And if you disagree, then we're going to learn for next time, okay? Kind of a feedback loop. And again, this LLM also uses both the information of the ticket and also the information in the source code. All right, next step is creating security review questions. And just think that those security review questions can be automatically copied into a comment on the same JIRA ticket that was created. So you get the conversation between the developer and the security practitioner starts, conversation starts rolling, and the developer is more aware of what are the measures that they have to deploy in their code. And just when the code is starting to be written, I mean, no single line was written at that point maybe, and already we have, actionable questions that the developer can have in mind when he's writing his code, her code. And I think that's like a revolution in a way. Like,
how regularly do you store this?
I'm sorry, can you repeat the question?
No, you were saying that this information you've gathered, you basically training them at some point. Train them, then you basically assign them, you basically put them into the vector. How regularly do you do this?
You mean how often do we train our models? That's a really good question. So whenever, I think the question is how often do we train our models? And first, I mean, before we released the feature, then it was trained up to that point. And then once we gain enough data, we're going to do a retraining, or once we see that the model starts, to perform in a manner that is unsatisfactory. Let's say we get a lot of negative feedback, or we're seeing that the performance is degrading, then we're going to initiate a retraining phase. And I think those are the main points in time. So that's, I think, like, this is super powerful, okay, where we can again automatically at no time get security review questions, and also a threat model created for every interesting, like, kind of a risky ticket that is initiating a design, that is initiating development. And we can have the code being written where there are certain countermeasures already taken in hand before development begins. Okay, I think that's super powerful. And here you can see, for example, the automatically created threat modeling stories. So we're talking about a chatbot that uses AI. So for spoofing, we can say that there is a danger of impersonating a legitimate user and stealing their sensitive data. And for tampering, we can suggest intervening in that space between the model and the backend service. And there are more. And just this is just a summary. We've walked through why secure by design and threat model process are beneficial, why are they important, but then on the other hand, why are they not happening all the time everywhere? And then I've shown how we can use LLMs, large language models, and AI in order to automate that process and aid in that way. And what it gives you the ability to have to know all the tickets, like all the designs that are happening, which ones are going to be risky, which ones might introduce risk into your systems, and then contextualize them with the entire world of Piro's deep code understanding, having to know where they're going to be deployed, why are they being risky, but not only that, but also having those countermeasures and remediation steps generated automatically. So that's it. Hope you enjoyed it.
You mentioned confidence. I have a question for you. Every time I use LLMs and I ask them the question, how confident are you? What I'm getting in response is actually a hallucination. Because so many times I ask something and say, how confident are you? And it gives me like 98%, but the answer is totally wrong. So the question is, have you come across this problem with LLMs? And what are the methodologies or techniques that you're using or people can use to overcome this Gen AI problem of hallucinating or making up the confidence level?
Okay, that's a great question. Thank you, Sam. I think, well, first of all, hallucination, definitely huge bummer, gonna agree on that. But I think that specifically when it comes to confidence, then I agree with you. It's very hard to get LLMs to say how confident they are. And the reason that we are getting it is because it's a fine-tuned LLM that we've trained ourselves. So we've actually given it thousands of data points where, you get the ticket, you get the code context, give us a number. Like, don't give anything else, just give us a number, like thousands of times. And it was trained that way. So that's why in that case it works. But I agree, it's an issue.
Yeah, so the question is does the change of the temperature help the confidence level?
I think in this case, what helped the confidence level was just the fact that it was, fine-tuned with data that, you tell what's the input, what's the output, like that's the answer for that. But decreasing the temperature definitely helps on other cases as well. And it's a technique we're also employing along with changing other hyperparameters. But it's also.
But on-train model, I think, was very important because so many people just using ChatGPT and they just using RAG and they don't provide their own training data. Paul, yeah.
Yeah, hi.
But I want, okay, I'll say something about that.
So yeah, thank you very much. I'm wondering whether you had a chance for some of your customers to try this and what sort of feedback you've had from customers.
Actually, I have a guest here who can speak for that, but I don't know. I don't want to put him on stage. I don't want to frighten. So we've just had a meeting today, and we've actually got good reviews. I think they were saying that, you know, if it wasn't for that feature, then they just wouldn't look at designs and they wouldn't have time for it otherwise. I mean, it's something that unless they are being, you know, kind of fed with that information, and unless we, you know, the system tells them what's interesting, what they should look at, then it just wouldn't have happened. I mean, and that's the case for so many customers, because it's an important process, but a lot of the time it's like, who has the time for it? And, you know, we try to make it as, you know, as easy as possible for the customer. So for example, you can get an alert when a new risky ticket is added. You can have that security questions automatically be a comment on the ticket. So like just everything, I'm sorry, Sam, just everything in order to you know, bring it to them. Yeah, just to make it happen. And I just wanted to say one more thing, because you were talking about, okay, but most of the people don't have data and they use GPT. I think that in today's world, it's also very easy to create data. And first of all, I'm all in for Petra's idea of creating kind of a shared data set. But you know, I'll just tell you a secret. One of the methods that we use to get data is to generate it automatically with GPT. So you can ask GPT. I know everyone's like, oh. But it works, okay? You can have GPT create like, I don't know, 1 million jury tickets in a second, and then you can review it, okay? You can give it some notes, okay? I want it to be more realistic. I want it to be on that use case. I want it to like think you're a developer in that company, and okay, it works. I mean, it's not, obviously it's not the only data we use. It's just we're enriching sometimes our system with it, but it's a method, and inviting you all to try it and then train your own models. It's becoming easier every day, really.
Awesome. We had one more question here.
So first, have you tried to use any other of those right? Or so for your friend modeling, I've seen that you use type. Have you tried any other approaches or blend it together somehow? Results of it. The second, have you looked into using multiple agents in like OpenAI previously last month? For this month, they showed about scoring, so kind of in a cluster of different agents working together. Have you tried anything like this?
Okay. Thank you, Sam. So, okay, 2 questions. One, we've been using Stride so far, but I really like the idea of using more and combining them. I think we're also, because it's just a start. I mean, we're constantly developing and we're in kind of a beta phase. So I think we're playing with the idea of even for different threat models, also creating more actionable countermeasures, and we keep on thinking what more context can we create, what more information can we create that will be extra helpful for the person that's getting it. So loving the idea, totally. And the second question was, do we use example of OpenAI having like an orchestration of agents, right? So in that case, we're actually using 2 different LLMs. So we have like a chain of, you know, different large language models are doing different tasks. Each one is trained to be on specific, you know, their own kind of, okay, this is your input, this is your output. So it's a chain. It's not a chain of agents, but it's a chain of models in that case. Don't know if it's answering the question.
Great, yeah, I see there's one more question here.
Actually, I was having two questions. So one was covered by Stepanyan, like about how do we deal with the false positive. So now my question is like, how can we detect potential business logic bypass in relevant case cases?
Ooh, that's very good.
Wait, how do we detect what? How do we?
How detect the business logic bypass, right? The business logic vulnerability.
Um,
Like, if one user is using the another one.
Oh, well, I mean, we're going to, okay. So I think we're going to ask the questions, and raise those stories that ask, those questions and raise their attention. And then we can also show, I don't know, either the developer or the security practitioner, we can show what are the security measures that are taken in this repository, because we also scan the code, so we know does it have like this repository, which kind of authentication, authorization method it has, and then it all just comes together as to what should be protected. Is it already protected? Should you be protecting it now? Was that clear?
Okay, so that's the okay. Do we have a question? Yeah.
So you showed how the model thinks the ticket is restricted, so it's applied, and you have to go to the model thinks the ticket isn't restricted, also explain why, and is there a for feedback? Yes.
Thank you. Okay, so you're asking, sorry, if I understand correctly, you're asking about false negatives, right? Okay, yeah, that's a tough one. I agree. It's a good question. So if the model doesn't think that that the ticket is worth reviewing, then we're not going to show it. But I have a few buts here. First of all, we are filtering that detection phase by a threshold, okay? Because we have that confidence level, and we're gonna say if it's above threshold, then show it to us. If not, then don't. So first of all, that threshold, it can be altered, okay? So if you wanna have more tickets, I mean, it's a matter of what's more bothering you, false positive or false negatives, right? I mean, you're gonna have either, because life. And you have to decide. So I think, first of all, each one can decide for their own if they choose more false positives or more false negatives by altering that confidence threshold. That's the first. And then second thing, we're constantly going to look, in our internal, when we're questioning ourselves, we're always looking at that phase, like a little bit above and below the threshold and what's going in there. And then we're trying to understand, did we miss things that were just in the in-between? And also we're doing, our QAs and checks, and we're gonna sample some negative examples to make sure we didn't miss them. But I think in this specific feature, the false positives were much more painful, because you don't wanna burden the security practitioner with going through a ticket that is not really risky. You wanna make sure that what you're showing them are the, where the risks are going to come from. So we were very tuned into losing false positives as much as possible. And that's also the feedback that we got from customers as well, relating to another question that was asked.
Okay, thank you, Marcella. I think that's all the time we have.
Thank you.
Yeah, I do need to remind you that we do have a raffle tonight. So I'm going to show the raffle QR code one more time, so you can actually see. Okay, so if you haven't scanned it, please scan it. You get a chance to read this awesome VR3 virtual headset, and also we are going to throw in, speaking of threat modeling, a deck of photocopier parts which allow you to run threat modeling tasks and play with your developers. or with your team play the threat model game. So please do make sure you scan it. I'm not sure if that's the presentation. Now, because John's power, let me see from the USB-C. That's the one. 1 second, I'll rush. We need a.
Thank you so much. Thank you. Thank you. All right. Thank you. Loving this community. Look what they.
Oh yes, you will also get this.
Cool. Yeah.
Let's see if we can do it. And run out of slots. Okay, we're gonna put it back and check. Still there? Yes, it is here. Okay, and let me share my screen. Okay, excellent. It's like this. There.
And I have one more file to open off the USB.
Okay, so but it is plugged in.
Yeah. Can you open up the folder?
Okay.
Yeah.
That will be which one?
The PNG.
This one.
Mm-hmm. Yep.
Oh.
It's a draw.io file. Okay.
It's gonna be a bit tricky.
Yeah.
You should be able to do it, right?
Sure.
Okay.
I figured it out.
We'll figure it out.
Yeah.
Okay.
It's okay.
Okay. I think
Cool.
I'm sharing. So
Yeah.
Hopefully this is right. Okay. We are slideshow mode. Okay, right. So I'm going to introduce John. John is our guest all the way from California, and John is quite famous in the cybersecurity circles because he presented a Black Hat at DEF CON numerous times. He's an active member of OWASP community in California. He presented many talks, mostly I think at the beginning about .NET vulnerabilities. Then he switched to blockchain. Speaking of blockchain, we have an NFT tonight. And then he moved on to the AI world, right? But there is a very interesting fun fact about John, right? So I told you a fun fact about Petra because she's actually a doctor, right? Very interesting fun fact about John that many years ago, if you remember when Snowden drama happened, what was going on? The NSA was trying to get ethical hackers to help them out. And there was a Black Hat conference, and the head of the NSA, General Alexander, was speaking. He was trying to get ethical hackers to help the NSA. And John was the person who actually heckled him, and he shouted, "Bullshit!" The recording of that talk is available on YouTube. You can go and find it. This is the Black Hat 2013. I'd like to ask you to give a big round of applause for John, who came all the way from California.
Oh, thank you. And it's really awesome to see how strong the London chapter is, and truly impressive to see OWASP around the world. I gave this talk at AppSec USA a few weeks ago, and this is the speedrun abridged version. But I'm trying to bring back all of I've been in AppSec 15 years, like what I've done throughout the years in blockchain and FinSec and now AI, but trying to bring the best practices back to the community and help make it a little more practical and hands-on. So you can see the main talk where I go through this in a bit more depth. I'm just going to cover the first one, but I cover how to DDoS, what happens if you get malware in your enterprise, how do you go about doing triage against an APT. But this is the speed run where let's begin just with the PII. So you're in an enterprise and your developers have just leaked all of your customers' PII to the internet. You're the security engineer. They come to you and say, this is your time to shine. Jump in there. You've been exposed. Your sensitive data is out there. It is scary. We've all been in a situation where you don't know what you're doing next. Some of the key takeaways: make a ticket. Start documenting this. You're going to need to go back 3 weeks from now when you haven't slept for 2 days and give a full report and accounting. So cut a security ticket, give it a PII date. And this is kind of your beginning of your documentation. And you're going to throw in something like, oh, what has happened? We've leaked the PII. The risk level is high. Who is it impacting? The response priority. And I'm trying to give you, just breathe for a second. This takes 2 minutes, 5 minutes, 10 minutes. And you're looking at a rapid assessment. You're now going to go through the time box of 30 minutes. You're not going to end up in analysis paralysis. Just cut a ticket, start making documentation, have tactical and practical outcomes of what's been hit. All of our user data is out there. Our critical PII, we've understood what critical PII, it's home addresses, critical numbers, account numbers. Legal has been notified and says this is critical. Leadership has eyes on it. And this is not the first time. And maybe you're lucky enough to not be the only security engineer facing this on your team. Maybe someone else is able to pick up the slack and come after you and follow up with your team. You're looking at, how did this happen? What systems got hit? What data? What storage? And this is where you sit down with your team and start understanding what has just happened. So out of the rapid assessment, look at notifications. Who are you sending this to? Legal, management, customers, marketing. And this is where hopefully you've thought ahead months beforehand of, if we have our customer data hitting the internet, what is our legal stance on this? Our marketing, how are they going to message this to our customers? What kind of SLA are we going to have to notify everyone your password has been breached? Please know your account is now shut down on our service, and marketing has a run book for how to respond to this. And these are all the things that you can do now. And I recommend just playing, what do you wish you had done if? So if your critical database ended up on the internet, what do you wish you had done? Maybe your management is a key stakeholder, and you need to be very sensitive about how you communicate this to your VC funding or whatever. That you could think now, what do you wish you had done if your network is compromised and you have intruders in your network? How are we going to notify our customers about our service going down? So, and how to stop this the next time, that's our real job. We're the first responders that get the notification. We processed it, we boxed it, we said, this is the problem. And now what? How do we communicate to our teams that we're fixing this? How do we go about actually remediating this? And this is the SDLC. This, when we talk about threat modeling, what is threat modeling? You're going to sit down with your engineers and they're going to say, well, this has been breached. This is what got hit. It's called Project Maple. We have ML models exposed to the internet. This has Dynamo and SQS, and we have basic authentication. This is Project Maple. And they show you this design document. Hopefully you're doing this months before the breach. Maybe you're doing this in response to the breach, who knows? And this is what engineers will bring to you. They'll say, oh, we have a gateway. Our gateway goes to a load balancer, and here's our databases. And it's very pretty and very professional. But to a security engineer, it doesn't mean anything. Like, you can't do security against this. And we have, I'm not, yeah. Oh, and can you click it? Oh, if you go back into the, if you open it into a presentation mode, it might be clickable. Tech is hard. And We could, it's actually a different.
Okay.
Okay, can you open up the slide into presentation mode? I totally know how to do computers also. So, oh, it worked in dev. Yes. Coming from the US, someone might have forgot their power is no.
No, try again. Okay.
Oh.
It's trying to open the PDF. Okay.
Oh, it's security. It's fine.
Oh, okay. Is that the one?
Yes.
Awesome.
So I don't know how many of you. Yeah. How many of you have done run books with your engineers or done intake? Nice. Okay. Awesome. And so this is kind of an example. I time box everything I do in security. I try to get it to an hour or a half hour. If I'm going to do intake with engineers, this is, I did this entire intake with one of my engineers in less than an hour. So some key information, what's the name, what's the system, maybe there's a code name, a version, edited, just high level documentation. Who is this impacting? Infrastructure, users, ML, product, data engineering, priority is medium, executive summary. And this is just kind of like, what is your system? You can give this to another security engineer, and in 5 minutes, they can come up to speed on it. What is exposure? This is gonna touch user data. This has publicly exposed endpoints, just some basic documentation. This is really what helps in a breach. Who are your key stakeholders? Who are the points of contact? And really, as a security engineer, as a living document, every time there's a design review, maybe you're doing requesting changes to the project or security approvals, you can keep all of your links in here, and I recommend doubly linking everything. So when you have all of your security approvals link to this document links to your security approvals, this document links to your design reviews. And so everything can be, you can pull up this document, go to all of those, and all of your artifacts, all of your, what is the GitHub link, system documentation. And this is kind of just, I don't spend any more than half an hour with my engineers the first pass. I try to make security easy. We just fill this out. It doesn't have to be complete. I tell my engineers specifically, do not fill this out incomplete. I mean, don't fill this out fully. Time box it at half an hour, fill in what you can, send it to me, we'll do a meeting. This is a living document that's going to live for the entire life of the product. When you have pen testing reports, add them here. When you get sign-offs and approvals. This is an intake form that lives through the entire life cycle. And when you have that breach, you can pull this up and jump straight into it. You can know who to contact. You can pull up all the security reviews. When they say someone's going to be fired for approving this, you have who approved this. And, you know, and it's documented and recorded. And so when this does actually get breached, you have this SDLC, and you bake security into each stage of the SDLC. But this is really what the SDLC looks like. It is madness. It is multiple teams, stakeholders, and you're trying to play catch up constantly, but you're trying to stay ahead of. And thanks to AI for helping me generate these amazing SDLC images. And so this is what we're facing as security engineers. And that's what I'm here to help with, is show that you talk to your team, you get your architecture review, you bake it in security into every stage of your SDLC, you keep documentation, you document what has happened in this breach, and then we do secure by design. And this is the, okay, this is where it's gonna get real kind of special. So how many of you use draw.io? Wow, oh my, okay. Ooh. Okay. So this is what your engineers walk in with. They're like, okay, we have our databases. And this is, maybe this isn't even, they don't draw this out. They just whiteboard it with you. Or they just explain it and you whiteboard it, but you time box this at half an hour. And you go back And you turn it into something like this, where you have a load balancer coming in, you have your user section, the user database, some of the user functions, and then it comes off to your backend. And you start kind of pulling it apart and decomposing it into something useful to security. And you do this with your engineers in another meeting. Or you do this and you present it to your engineers for, now this is how I'm looking at your system. And again, half an hour, maybe it's a week later, and you say, okay, I've reviewed your system. We need to talk about input sanitization. We need to talk about authentication. Here we're going to start talking to the engineer, and really the secret sauce is you're saying this is a red system or a critical system because this has user PII. And that is more important than all the security controls up front. And what you're going for is getting a common language and agreement from your engineers that this is PII, this is red data, because at this point they can say, actually, no, it's not sensitive data, and here's why. And you can have that discussion. And you really need to get the buy-in from the engineers at each change in this system, and this system architecture reflects another part of the system and more PII, and it goes to a data lake. And in the data lake, you have prod data and AI analytics. And you start pulling apart what the system really is. The engineers say, we don't have any bandwidth to do input sanitization or authentication. And you say, okay, I'm gonna pull them out of the design. And this is their agreement for how the system should be designed and what the design of the system is. And if your engineers say no, your security, you can advocate for it. They can say no, and you can do a risk acceptance and say, okay, we could take this to management that we're not going to do input sanitization. Or you can go to QA and help them understand how to do attacks that would leverage input attacks. But you start filling out the system, you start finding KMS keys, you start identifying more parts of the system. And by the end of it, you're starting to build out a more complete understanding of the system. And just to give a little bit of a flavor of, this is kind of how I represent a security boundary. This is input sanitization. This is the internet. This is what we're defending against. This is DOS level protection. Maybe this goes to Q4 next year, which means never. But we start identifying our business logic defenses. So maybe we're going to look at, it's a fintech and we're not going to take negative numbers on money. Or when we have login and detection of user activity and data access, we're going to do it here. And you can start kind of slicing out, so red for scary, orange for problem, green for I should never get attacked here. And we have different types of security at each level. Typically red is more about defense and stopping. Orange and green are more about defensive boundaries and logging and detection. So on our guts, we mainly do logging and detection. On our outside, we typically do more of a hard shell. And this is where you kind of communicate to yourself, your engineers, other security engineers. I wouldn't show them all of these. It would more be for my internal team of identify these types of attacks. And remember when we talked about this is user data, this is red, those many meetings ago, this is where we start coming into the PII breach happened here. And so, or maybe you're just a security engineer looking at this and you're like, none of this system matters except for the PII. This is what I care about. And so how do you go about defending that one point is pretty much what our job is. We say input sanitization, sure, we're not doing it. DDoS detection, yeah, you know, I'll try to come back to input sanitization. We're going to just accept DDoSes, but this PII, that's what I care about. Everything else can go by the wayside. And so here's a design idea as opposed to a security control. We're going to make it write only. We're going to split the PII away from the rest of the system. And we're going to say, okay, we're going to alleviate this system of having PII. We're going to move it out. We're going to segment its logic. We're going to make it write only, so there is no read capability. We can lock this down with whatever compensating controls to make sure even if this gets compromised, like someone can put bad code here in GitHub somehow magically, it literally doesn't have the access to read the database. It could corrupt it. It could do all sorts of other things. And this is where we can start building defensive layers, not with security controls, but merely with design changes. And this is where your engineers come in critical, is they need to agree to this design change. You as security, you're not going to come and split apart the code base and change the functionality and maintain this going forward. And so in the weird way, all these other security controls of the WAF, the input sanitization, maybe even KMS keys and the rest of the system, this design change is what protects your PII. And you can horse trade, you can barter the other security controls of, I'm not gonna make you do DDoS mitigation. We can push that off to Q4 next year, never, but we're gonna focus all of our engineering effort and get this out within 2 months. We're gonna get this segmented and split and tested, and we're gonna prioritize this. And you can start saying, I'm not gonna make you install Cloudflare, a WAF, input sanitization. I'm gonna still need authentication. We're gonna need this, but we're gonna prioritize the splitting off of the PII into another area. And then you find that on the back end, there's AIs and dragons, and there's unknown threats lingering out there. And where is the going back to the talk? Yeah. Okay, and then slideshow, current slide, look at that. Thank you. Tech is hard. And so you go through the design review, hopefully not when this is breached, hopefully months beforehand. And this is how you tackle engineers coming in with some random architecture. You actually split it apart, you pull it into its subsections, you start working with your engineers to get a common language. And what's most interesting is when you actually work through this with your engineering team and you take this to operations and you show it to them, they're gonna say, that's not actually how the system works. It's actually deployed or built in another way. And there's Kubernetes containers. And then you start laying out your architecture, incorporating the Kubernetes containers. And when you talk to multiple teams, you'll actually come to multiple understandings of what reality is. You put it in that one design doc, and now everyone has to start agreeing on a common reality. So it's actually a really powerful way to get multiple teams to understand their own system, because nobody does architecture for their systems. I mean, does anyone in here have your developers actively maintaining architecture diagrams? Awesome, 3. Like, in real world, I would love to see all the engineers have actively maintained architecture diagrams for every system, but I've been an engineer, I've been developing software systems, and it's like, well, it's documented code, it's in GitHub, you know, like, and, but every one of those security controls that I showed you in these previous slides, every security control has to have an owner. We have Cloudflare, who owns it? Not the developers. It's either operations or security. The input sanitization, who owns it? Developers and security. Now this needs to have pen tests. This needs to have validation. This needs to have regression checking. This is now something that will forever cost the security team and the company engineering resources, and you can only have so many of these. But the nice thing is the designs. The design of splitting off the write only doesn't necessarily have to have an owner. That's just an engineering feature of the system. And that's one of the most interesting things, is you have security controls, metrics, monitoring, pen testing, validation on defenses. On designs, you just have features and functionality that's inherent in the system. And from a security perspective, how much effort do you have to put in that this system is segmented? You need to maybe check on the write only. You need to make sure that there's a separate VPC. You can do that once every 6 months, and you can support a large number of designs, whereas how many security controls? Your team is probably 1 to 4 people of security engineers. You're lucky if you have 4 security engineers. And how many security controls? Let's say you have 50 types of input sanitization all over your system, and you have 10 WAFs, and you have 100 endpoints. And they're all secured with bespoke, unique security controls, and a security engineer has to be responsible for them. As a security engineer, how many can you manage, maintain, do your day job, and make any progress? And so that's where, if you can break down defenses and the design choices, it's really powerful to try to design systems that are just secure. And so that's one of the real superpowers, because you can have thousands of designs, whereas defenses, you might only get a few. And so when you do recommend a security control, you're going to have a WAF. You want to have as few as possible, and maybe you have no more than 10, maybe 20 security controls that your team can actually support in an ongoing way. When you talk about designs, you get in there and you work every single sprint, you work every time a new system is designed to try to get as many security designs to make the system strong and capable. Yeah.
API gateway. I said we have previous PPT, like we can protect API gateway through the web. So like how we can protect the KMS.
Question, how to protect the KMS? Sorry.
No. Yeah. Okay. So let's say your data is protected in a database and you have KMS keys protecting your database. For the write-only functionality, you can set, I'm from the AWS world, so I apologize. You can set your KMS keys to encrypt only. And so you can have Lambdas or EC2s or different systems have access to a KMS key, but in encrypt only mode. So they literally can't call decrypt on that key. And it's enforced by the KMS system, and it's enforced by an IAM policy. And then that IAM policy, you can set that to anytime a IAM policy needs to be modified, then it needs to be put through the security review. And you can even set your PRs to literally have one of the security team do the PR review for any changes that impact that IAM system. And so you, any more question? Okay. How to secure your DNS systems. No, but it's a good one. And ironically, I come from over in the crypto world, and we've been destroyed by having our DNS hijacked. I asked my friends about securing their DNS, and it was DNSSEC and another recommendation. I have it up on a Twitter account of best practices for securing your DNS. But, and as an OWASPer, I really do want a cheat sheet on securing DNS. Like, that would come in very handy for me. And does that answer your question? Or I'm happy to talk about encryption in any way or scale. Okay. Okay. So you're looking at your security budget, and your budget as in resourcing and energy power of your security engineers. And this is where burnout comes in. If you have responsibility for your day job, your security reviews, maintaining your relationships with your teams, and security controls, and pen testing those security controls, that's where you come into burnout. And so if you have development and you have good practice and you have a culture that supports designing security into the process, and then if you do have a security control that you need to require, you push that. If you have a security control that you need to do a risk acceptance for, and you're going to escalate that up to the team. And I recommend that you review all of your risk acceptances at least once a year and keep track of every single exposure to the internet, to your partners, and make a policy and procedure every time we're going to make a new connection to the internet. You're going to have to get your CISO to sign off on it, because your CISO not knowing about a zero trust boundary that's now exposed to the internet, your CISO not knowing that you're having a new partner API gateway come into your guts, completely changes your threat landscape. And this is where you start enforcing good culture and best practices and the design reviews, and you start making choke points that are not security controls, they're just best practices. And it's like, sure, send it to the CISO. The CISO says, I acknowledge I got this. They can come and block it next week, but they at least were notified and can have a chance to block it. You try to not make a blocking process that security is a blocker until they're notified. Security just must be notified. And security can do what they want. But your real goal is to build trust with your team, and you're trying to get every SDLC process to have security. So when you're designing your product, when you're going out and scoping, building a new authentication system as security, you're advocating for 2 months instead of 1 month to build authentication, because you're going to need to do pen testing. You're going to need to do extra reviews, and your engineers are going to be genuinely surprised that it's going to take 2 months. And if at the early stages you can say this is going to take 2 months, your engineers can plan 2 months. And that's how you build trust and relationships with your teams. That's the end of the talk. That is a speed run. I'm happy to go in depth, and there's a longer talk from AppSec USA coming out relatively soon. Thank you.
Time decisions you make this service isn't exposed to the internet. This service hosted in Europe is taken by and PII.
Oh.
If sometimes those assumptions can change in the future, that may invalidate designs you've made before. Do you have a good systematic way of an assumption changes, figuring out what this whole is revisited or reviewed? How do you capture or encode those assumptions that underlie your project?
Nice. Oh, excellent. So in the SDLC, we have it patterned for building new systems. And when it comes to maintaining old systems and making upgrades, yes, it definitely is harder for security to stay up to date because they're continuously changing. My really strong go-to is if you start the SDLC, not where I'd prioritize it, but where it starts to, it skips your product designers for the application. It's probably not going through them, but it's almost certainly hitting your DevOps team, because there's going to need to be a new network exposure to the internet. And hopefully you're doing centralized ingress egress to the internet. And so any changes to that are controlled by your ops team. And your ops team knows that any changes to the internet need to be signed off by your CISO. And so now your CISO gets notified that a new internet exposure is happening. Even worse is when one application is now piggybacking upon one endpoint and it's splitting off now to 2 systems. That's where it comes into the culture of all of my meetings are less than 30 minutes. So the engineers know when they contact me, I'm going to do a rapid assessment. I typically really try to do an SLA of same day. And I try to do non-blocking half-hour meetings. So if they do escalate something to me, I'm not going to use a week of their time, block their project. It's a half-hour chat. And it is the engineers, operations, and ironically, I'm starting to come around to software infrastructure as code as one of my better places to put choke points and detections and auditing. Unfortunately, even on some of the most secure systems with the best culture, I still had engineers that were building a new type of authentication system, and the administration portal for that system was exposed to the internet, and they didn't consider the authentication system to be in scope of security, saying any exposure to the internet must be run by us. And so that's where audits from external pen testers that focus specifically on your exposure come in. getting someone that does OSINT. They run down your subdomains. They actually come in and check your infrastructure and challenge what's exposed comes in. And really, if you can catch it within 3 months, you're probably ahead of the ball. If it sits out there for 2 years, you're almost certainly going to get hit. If it's out there for 10 years, you're definitely going to get hit. So it's more about how do we make sure at least once a year we're going to catch everything? How do we make sure if something is unsecured exposed to the internet, it's within 3 months? Yeah. And thank you so much. And it's really nice being out here in London. It's definitely one of my favorite places to come and meet OWASP. So, and thank you, Sam. It is most amazing.